Hello folks, and welcome back to the channel. Thanks for joining me. Today's video is in response to a number of comments that I've had about my diesel heater videos I've put up on YouTube, and that is how many amps and how much power do these units actually take out of your batteries. So what I'm going to do, I'm going to sort of do a real-time test and measure the actual ampage and the amp hours used, and give you a figure for what my setup uses. I'm going to be using one of these meters. These little devices are really quite good. They'll show the voltage, the current, the wattage of whatever you're testing. So all I've got to do is wire it in line to the power feed to the unit, and it'll give us real-time results. So I've run a new live and earth to the meter using these quick connectors and joined the other side, the load side, to the burner unit. I expect the heater to take quite a fair amount of time to get up to temperature, so I'm only going to do a test to raise the temperature of the van up by 10 degrees. That will give me a indication of the amps used to get to temperature. So I've used 25 amp rated cable between the fuse box and the burner unit. It's twin core. I just bought a roll because I use it for all the electrics in this van.
And now I can replace the fuse and power up the unit.
Okay, so the current temperature is 11 degrees and I want to raise it up to 20 degrees. Battery 13.5 volts, no errors, and that's the time at 0. So we'll start the test. When you turn on, the fan comes on straight away and the glow plug.
And what you can see on display is the battery condition, the amps being used, and also the watts being used. So with the fan and the glow plug on, we're getting 7.6 amps, and after a minute the pump cuts in and we still get 7.5 amps. There's no heat generated yet because there's nothing showing in the display, but after 3 minutes we've got 2 or 3 bars of heat and we're ticking over at nearly 3.5 amp. And finally we've got a full burn, the glow plug's off, fan on maximum, and it's drawing 2.95 amps. We've got a full display here of heat which indicates a full burn, and the temperature at the hot air ducts is 92 with the fan running on maximum. So to recap on what's happened so far, the unit has been running 5 minutes, it's done all the safety checks and it's done the warm-up procedure up to give maximum burn rate, which is in this case 93 degrees, and during that time it's used a total of 0.295 amp hours from my battery. It's been running for 8 minutes now. At full burn rate we're using just under 3 amps. It's 13 degrees and it'll carry on running at this maximum burn rate for as long as it takes to reach the predetermined air temperature that I've set it at. So I'm going to let it carry on and come back when it's reached that temperature. 57 minutes in total now, and it's got the temperature up to 21 degrees, and if you notice it's slowly throttling back on the fan, and I would assume the pump rate as well, because the amps we're using is slowly going down. And after 58 minutes we're running at under half an amp to maintain that temperature. And at 1 hour 3 minutes it's reached temperature 21, which is a 10-degree increase, and on average it's been using about half an amp all the time. The overall ampage used so far is 1.786 amp hours. So I'm going to shut it down, and you can see immediately that the glow plug goes on and it starts ramping up the ampage used. And after 1 hour and 4 minutes just the fan is on, and you can see by the coloured temperature indicators that we're down to 2 bars now. And finally the whole unit shuts itself down completely, and the 2 bars shown seem to equate to under 30 degrees before it turned off. And finally we've used 1.916 amp hours of power, or 24.4 watt hours from the battery.
Well, that's the test all done now. I've had to take my top off because 21 degrees in here is just a bit too warm, and at least I know now that if I want to raise it up 10 degrees from 11 degrees to 21 degrees, that will take me a total of 1 hour. This test is very specific to my motorhome. This motorhome is very well insulated. It's got double glazing, window blinds, curtains. It's got all the things that make it heat efficient. On the downside, of course, it's a very big van, probably 3 times the size of your average camper van, so the volume of air that's needed to be heated is quite a lot more. But overall, the ampage used for these heaters will be more or less the same regardless of whether it's in a small camper van or a big motorhome. So the initial startup, where the burner done all its safety checks and got the heat up to maximum burning temperature, that took 5 minutes, and it used 0.295 amp hours of power from a battery bank. Now during the phase where it was heating up the air to the 21 degrees that I'd preset on the controller, the burner was running at maximum, the pump was running at maximum. That took 58 minutes, and when it got to temperature, when it got to 21, there was a total of 1.787 amp hours used from the battery. And finally there was the shutdown phase of the burner. That took another 5 minutes, and when it shut off, the final amount of ampage used from the battery was 1.916 amp hours. So for startup, run to temperature and shut down, it's using on average a maximum of, round it up, 2 amp hours from a battery. And finally, when the controller reached the 21 degrees, the burner throttled back and reduced the fan speed and the pump rate to almost a tick over level, or a maintenance level, in order to maintain that air temperature. And while it was doing this, it was running at under half an amp. So if I want to run the burner for a further 2 hours, I just need to add 2 times half an amp, and that gives me 1 amp hour, and I need to add that to the 2 amp hours that we've previously got. So these are the sort of figures I finished up with. The startup, raised to working temperature and shutdown, which took 1 hour, that used 2 amp hours of power from my battery. Then to maintain the running temperature, worked out at half an amp hour for every hour that you used it for. So as an experiment, if you wanted to run the heater for 10 hours, you'd have the 2 hours of startup plus your half an amp times the remaining 9 hours, which is 4.5 amp hours. And to run constantly for 10 hours, you'll use a total amount of power of 6.5 amp hours out of the battery. And taking it a bit further, if you wanted to run for 24 hours,
the maintenance running time is longer, and you'd use 13.5 amp hours of battery power.
Now I know there's going to be slightly different values for different vans and different setups, different temperatures, but on average I think those are the figures that you can allow. So if you've made it this far, well done. Thanks for watching. I hope it's been useful and helpful to you, and it's kind of answered the question of how much do these heaters use. So for now then folks, stay safe, take care, and I will see you on the next Wrinkly Nomads video. Bye for now.